Okay, so I've got some definitions here of local and absolute extrema. Now, I'm not going to read through all the definitions. I advise you to pause the video now and to copy these down in your notes, in addition to the example. And when we finish, press play and we'll continue. So, if you're back, in general, one thing to keep in mind is the word extrema. That's plural for extreme. And if you just think of, everyday life, what the word extreme means, extreme temperatures mean temperatures that are really hot or really cold. And an extreme sport is a sport that happens to be really dangerous. So in math, the idea is the same. An extreme value is a value that's really high or really low when you compare it to the other values in the function. Okay, so the definitions are there, but what I think the best thing to do is to look at the example and kind of go through each definition and see what fits, which definitions apply to certain pieces of this graph. Okay, so we're expected to determine the absolute and local extrema of the function below and where they occur. All right, so let's start with the first definition. A local maximum value of a function f is a y value that is greater than or equal to all y values of the function in its local neighborhood. So can we find a y value on this graph that is greater than or equal to all y values in its local neighborhood? Let's see. Let's look at this first point here, -1, 1. Is that y value 1 greater than or equal to all y values of the function in its local neighborhood? Well, what I mean by local neighborhood is if I move a little bit to the left of the graph, if I move a little bit to the left on the graph at the point -1, 1, if I move a little bit to the left, well, there's no graph there at all, so I really can't move to the left. If I move to the right, the graph starts to go up, right? So therefore, 1 is not a local maximum value. Okay, it would have to be bigger than or equal to all y values in the immediate neighborhood, and it turns out it's not. Go to the point 1, 3. Okay, if you put your pencil on the graph and imagine moving a little bit to the left, the y values go down, and a little bit to the right, the y values go down. Right? So could we say that 3 is a local maximum value? I claim that we can because it is a y value that's greater than or equal to all the y values of the function in its immediate neighborhood. Okay, so this is I'm going to write local, L for local max. Now the directions say to state where they occur, so I'm going to write over here, there's a local max of 3. And where does it occur? It occurs at x equals 1. Okay, is there anything else that might fall in the definition of a local maximum? I think if you scan to the right, you see that at 5, 2, we have a point that looks like it's sort of the maximum point on this graph. And according to the definition, it is, because if you move a little bit to the, if you imagine standing here, if you move a little bit to the left, you're going down, a little bit to the right, you're going down. So we've identified a local maximum. Okay, a local maximum. And I really should say the local max, technically the local maximum value is 2, and it occurs at 5. Sometimes we mark up the picture and sort of point at the actual points and call them maxes and mins. But technically what you should do is what I'm doing out here, which is to write there's a local max of 2, and it occurs at x equals 5. Okay, so I think we're done for local maxes. How about absolute maximum value? Well, the absolute maximum value, it is the y value that is greater than or equal to all y values of the function. So we want the y value that is bigger than or equal to all y values of the function. And if you sort of look at the picture closely, you see that the biggest y value, and the y value that's bigger than or equal to all the other y values is 3. So we're going to say B, we're going to say the absolute max is 3, and that occurs at x equals 1. So notice a local max can be an absolute max as well, right? And this makes sense. I mean, if you're the an absolute max is always a local max. I mean, if you're the best soccer player in the world, you're also the best soccer player. You're also the best soccer player in your town. The reverse is not true. If you're the best soccer player in your town, you're not necessarily the best in the world, and that's where the 0.52, or that local max of 2 at x equals 5, it's a local max, it's not an absolute max. Okay? Moving forward, how about a local minimum value? Well, if you look at the point -2, 1, we see that if you move a little bit to the right on the graph, you would be increasing, and the y values would be increasing. That means that there's a local minimum of 1, and that occurs at x equals -1. Let's call that a local min. By the way, I should have also noted that that is the absolute max. Okay. Any more local mins? Well, if you look at the point 4, -2 right here, right according to the definition of a local min, minimum value is -2, local minimum. Well, if you move a little bit to the right or the left on this graph, your y values are going to increase. So that means that we also have a local min of -2 and x equals 4. Okay, so there's a local min. Now the question is, do we have an absolute minimum value? Now the trick answer to put here is that the absolute minimum value is at is -2 at x equals 4. But you got to be kind of careful when you're analyzing these graphs, because if you look over here, I put an arrowhead down there to the right. Now I probably should have made it more explicit what that arrowhead's doing. I mean it to be going down. I mean it to be decreasing indefinitely. So what that means is there is no absolute minimum value. Okay, there is no y value that's less than or equal to all the y values of the function, because if you give me one, all I gotta do is move a little bit to the right on the graph and I'll be lower. Okay, so there, in this case, there is no absolute minimum. No absolute minimum value. Okay? In practice, these are, this thought process is a little easier, or a little quicker than what I made it out. But the key idea is these definitions. Okay, these definitions are precise, so you want to make sure that, in particular, you don't fall into the trap of identifying something as an absolute minimum or maximum when there really is none.